Hello guys, welcome to the channel. Today I am going to show you how to use WheelCollider in Unity3d. In this video, I am going to use WheelColliders to achieve realistic car movement. As you can see, the wheels are turning and suspension is also working. First of all, I am going to add a rigid body to my car and set the mass to something like 3000. Box collider is also required to detect collisions. Make sure you check the Use Gravity checkbox in rigid body component. Now I am going to create an empty game object inside my car. Move all the wheels inside this game object and name it as wheels. Then duplicate this object and select all the wheels, and then remove mesh renderer component. This will leave us with the transform of wheels of car. Then add WheelCollider to it and set mass to 100. This is the mass of our wheels. Radius to 0.5, wheel damping to 1 and suspension distance to 0.1. Under suspension spring setting, set spring to 70,000 and damper to 7,000. Make sure to adjust radius and center property to set wheels collider position. You must set these properties according to your requirement and may vary from mine. Now create a script car collider. In this script, add reference to WheelCollider and transform component of wheels. Set steer angle to 25. This is the maximum angle by which our car can turn in either direction. Now set motor force to 1500. I am setting this to a large value because my scene is pretty big. And set a float variable to set the steer angle. Then I am defining two more float variables to get the horizontal and vertical inputs from user. Now create a function input to get input from user. In this function, write h equals input.getAxis horizontal and v equals input.getAxis vertical. This will return the inputs from of SWD keys and arrow keys. Then create a function drive. In this function we are going to write the logic to drive the car. We are going to write back driver cool.motor torque equals motor force times V, where V is the vertical input from up and S key, or up and down arrow key. Now we do the same for the other back tire. This will apply the torque to the rear tires, and it will look like the force to drive the car is coming from rear side. Then we create a function to steer our car so that it could turn. So first of all, we are going to write steer angle is equal to max steer angle times h, where h is the horizontal input from a. So to apply this rotation to car we are going to say front driver cool.steer angle is equal to steer angle. And we do the same for the other front tire. You can see we are applying force to rear tires and using front tires to turn our car. Now we are going to write a function to update the tire's position and rotation in world space. This function takes two arguments, WheelCollider and transform. First of all, we create a vector 3 pose to hold the position of the tires and create a quaternion rod to hold the rotation of the tires. Now we say get world pose. In this thing the out pose, an out rod will return the updated position of tire. Though we will feed these values back to the transform.position and transform.rotation. Then we have to call all the functions in the fixed update. But we have to call the update wheel pose function 4 times for each wheel once. Now our script is done. Save it and head over to Unity. Drag the script onto the car game object. and then set all the wheel collider references and the wheel transform references. Make sure you have set the motor force and steer angle according to your requirements. Link to the assets used is in the description. Now, I am going to make the main camera the child of car, so that it moves with the car. As you can see, our wheels are turning, and our car is also moving. So we have accomplished our goal. Now I am going to write a script for the camera to follow our car. First of all, I am defining some variables to use in the script. Object to follow will hold the reference of our car. Offset is a vector3 variable which is offset value of our camera. I have also defined look speed and follow speed. Function look@target is a pretty basic function. In this function I am storing the look direction of our camera by subtracting the transform position from object to follow position. Then generation a quaternion from it, and the using quaternion.lerp to update the camera rotation. Move to target function holds the logic to move camera to the desired position. In this method I have added the offset to the object to follow position and then used vector 3.lerp to update the camera position. Then I have called both of the functions in the fixed update. Inside Unity Editor, drag and drop the script onto the main camera. And hit play, you will see the camera will snap to the center of the car. This is because the offset is set to 0,0,0. Set the offset to a proper value. Link to the script used is in the description. If you enjoy the video, please drop a like.